Hello everybody, I welcome you all to my YouTube channel Robust Robots, and I'm Dhruv, and this is my first video on YouTube and I'm pretty excited about it. This video is the first video of a series which I'm going to make, and in the end of this series we will be able to make our own homemade robots using homemade items and some electronic stuff. So we are gonna increase the complexity of the videos gradually. So this first video will be very easy and it will be just an introduction to robotics and electronics and some of the common components used in electronics. So let's get started. So first we get to introduce to robotics and electronics. So robotics is the branch of technology that deals with the design, construction, operation and application of robots. So it is a branch of technology. In short, it is a branch of technology that deals with design, construction, operation and application and of robots, and it is basically the design, how to use them, their function, where will be they used, etc. And electronics is the branch of physics which deals with making of electric circuits using electronic components and using those electric circuits in various places. The use of electricity, etc. is called as the electronics. So as I said, in this first video, we will be getting introduced to various electronic components. So the first electronic component on my list is an LED. LED. So it LED stands for light emitting diode. So you know this is very basic component in electronics, and you see them everywhere, like your TVs. They are made up of really small LEDs, then other types of switches, etc. So this is an LED. It is the most basic component and frequently used component. So it is not only in white but it occurs in yellow, red and green colors as well. Here they are, and they are pretty easy to operate and cheap to get. Not just red, green, yellow, but they occur in various colors. They are in changing colors. They also occur in various sizes, such as this one. This is a bigger LED which is more powerful than these, and yes, it does require a lot of electricity. While like this one works on like 1.2 to 3.6 volts, while this one needs greater amount of voltage. This is also a bit powerful, and yes, they are very easy. So we will be looking at its structure first. So as we can see, it has two ends. One is a bigger end, which is this one, and the other one is the smaller end. So the bigger end is the positive end, while the smaller one is the negative end. If so, there are various ways to identify the positive and negative ends of an LED. So first one is by this method, so by judging the height of the legs. So the larger one, the longer one is the positive, while the shorter one is the negative. If we look at the center of the LED, if we look at the center of this LED, we can see two small parts of a metal plate. So if we look at the bottom, the longer wire is the part of the shorter metal wire, of the short metal part, and the negative leg is the part of the greater metal part, which is cut and restart. So if we look at this part in the center of the LED, we can see a big metal plate. So it is divided like in a diagonal way, not from the center, in two parts. So if we look below, the longer leg follows the shorter part of the metal plate, while the negative end of the leg, which is the shorter leg, follows the bigger part of the LED, a bigger part of the metal plate. So this is one of the ways to identify the positive and the negative ends of the LED. If and this can be used if both of the legs are cut at equal lengths. And one more is that if we move our finger around the edge of this LED, around like bottom of this LED, we can see there is a flat end somewhere. Yes, I found it. The flat end is at the negative leg. So this here, if you can see it clearly, is the flat end of the flat side of the LED, and this we can use to identify the negative side of the LED, which makes the other side as the positive side. So there are these three common ways of identifying the various, like the positive and the negative sides of the LED. So now we looked at the structure of the LED, and now we are gonna look at the structure of colored LED. So it is pretty much same as the non-colored LED. So the only difference is that it has a colored. They have colored tops, the green light and the yellow and the red. They have colored glass around them, and also their materials are different, a bit different from the ones used in the common LEDs, which is this one. So their both structures are different, not structures, but their both materials are different. So moving on to the next component. The next component on our list is our motor. So the motor in my hand works at 9 volts battery, and it is used almost everywhere, like in the PC, in the computer which we use. It is used in our fans, in our ECs, in cars, etc. So they also come in various shapes, they come in various sizes, they come in various torques, they come in various powers. So the power, torque, it is all will be described in a future video, but first the basics. So this, as we know, was invented by Michael Faraday, and it works on the magnetic effect of the flowing current. So we know that the flowing current through a wire produces a magnetic effect on around the wire. So it works on the same principle, which is called as electromagnetism. It works on the same principle. So that's it for the motor. So the next component on our list is the breadboard. So if we see here, we have got 4 sections. So this is the first, this is the second, this is the third, oh wait, I'm holding it upside down. So this is the first, this is the second, this is the third, this is the fourth. So if we see here, the first section has some holes, while the second has some, the third has some, the fourth has some. The first section is these holes are connected in a different way than these. So I have got an open breadboard here. So if we see here in the first section, these holes are connected. So yes, if we see here, they are connected horizontally. So all of these are connected horizontally, they are not connected vertically. So the first, this one and this one are not connected like this, they are all connected in a straight line going here. So this is the first section. Same applies for the fourth section. So if we look into the third and the second section, we can see that they are connected vertically. The holes are connected vertically, not horizontally. So these holes are connected like 1, 2, 3, 4, 5. These holes are connected like these and not these, like this. So they are connected vertically, not horizontally. So this is the basic structure of a breadboard. It is used in testing small circuits, like really small circuits and seeing if they work or not. So this is a double-sided tape, so we can stick it down here and it won't move. So we can test the circuits we made freely. So we might be using this in the future videos. So right now let's move on. And one more, if we see here, the breadboard has some edges, some crevices here. So these are for joining two breadboards to each other. Like if we see here, there are edges, and here there are bumps. So we can join these two breadboards like these, and we have a bigger breadboard now. Next component we have. So after breadboard we have got switches, and we use switches in our everyday life, like switching on the lights, switching on the fans. They use switches. So switches like break and complete the circuit. So if we see this switch, it is on right now, and if we flip it, it is off. So when it is off, it breaks the circuit and the electric current can't flow through the button. And if we switch it on, the circuit is completed and then electric current flows. So there are various types of switches. I've got some here. So this is a basic and on-off switch. This is an single push single throw switch, which is called as SPST switch. It has only one input, as we can see here. It has got only one input. Here these two screws are the input. And this, when pressed, comes up. So it can only complete one circuit at a time. So it is called as an SPST switch, single push single throw switch. So I single push it and it completes only one circuit. So it is called as a single push single throw button. So here we have got a common sliding switch. It is a really small switch. I didn't find a bigger one. So this slides, and it is a single push double throw switch. So it can be used to complete only one circuit at a time, but the switch has 3 legs, so it can hold up to 2 circuits at a time. So when the switch is over here, the circuit which goes from these two legs is completed, and when the switch is flipped to the other side, the circuit from these two legs is completed. So only one input, but 2 circuits are completed. So this is called as a single push double throw switch. This one is also common one when so all of these are switches. They are used to complete circuits and etc. So the next component on our list is our battery. So this is a battery. It is very much like a cell. So there are various types of batteries. These batteries are very small and are used in small testing circuits, and in using small circuits like the mosquito bat which we use, it uses this kind of battery, or various things. So it is when two cells are connected to each other, or when two cells are connected together, it is known as a battery. So of course a battery is more powerful than a cell. So there are only not this type of battery, but there are various batteries like lithium ion, which are rechargeable, nickel cadmium, which are known as NICD batteries, and lead acid battery, which is used in our cars or vehicles, and the power generators used at homes. So when the electricity is off, so the lead acid battery provides the current, provides the electricity to our house, but they give out a lot. But this one is a small one, but the lithium ion, nickel cadmium and lead acid battery give a lot of power and a lot of energy out. So this is a very basic battery. I have another one here for an example. So these two are batteries. Never to connect these two batteries like this, or they heat up very fast and it might lead to an explosion, just as a warning. So the next one, we have a cell. So this is a dry cell. This is a, I guess it is a double A cell. Yes, it is a double A cell. So there are various cells such as A, double A, triple A cells. There are button cells. There are solar cells. Button cells are shaped as a button. They are very small. These cells, they can provide very small output. So it is given here, battery output is like 1.5 volts. This battery gives out about 9 volts, and this one gives about 1.5 volts. So these are easier to use. These are used in TV remotes or electronic watches. The button cells are used in wrist watches. These ones are used in wall clocks. Also, not to connect these. No, these can be connected in series, but we have to be careful while using any type of electronic battery or cell. They can explode if connected incorrectly. So the next one on our list is wires. So we all know what a wire is. It conducts electricity. It is used in electronics. It is used basically everywhere, like the computers we use, the wall clocks, the TV monitors. They all use these wires. They are a source of conduction. So in an electronic circuit, the battery is called as the circuit provider, while this wire is called as the path, and the LED or any LED or a motor which consumes the electricity provided by the battery is called as a load. So this is a path, the electrons, this is a conductor, the electrons flow very easily through these. They are usually made up of copper. Yes, this is only one way. This is the only thing that I can tell, because there is not much in wires. So this actually wire is a two joint wires with each other. These two wires are joined. Yes, these two wires are joined to each other, while there are some wires that come in one pair like this. This only is a single wire. This is a negative wire. Black wires are usually negative, while the red wires are usually positive. So the next component on our list is used for soldering. So this is a soldering gun. We call it. This is a soldering gun. So it is used in various electronics. So the PCBs, which are the components on a PCB are connected by this solder gun. So not by this solder gun, but by the solder wire which we use with the solder gun, which is this one. So this is a wire, solder wire, and it is made up of tin. Actually, let me find it. Okay, so this is a solder wire which is made up of tin, which is not tin but mixture, and is usually tin based, means a lot of tin is used in this wire. So it melts about 100 to 200 in about 200 to 200 degrees Celsius, and this gun heats up to 450 degrees Celsius, which is very hot, and we should always be careful while using this. This is used in, and so like joining now this, if we see here, when on a PCB or a board, the components are fitted on the base, and then they are the components are soldered by this wire this wire is heated up by this gun, and then the metals, the legs of the components are fused to the board and are connected to each other, making a complete circuit. We will be doing this in a future video. The precautions while using the solder gun is that you never keep it lying on a floor like this. So now it's not plugged in, so it's not very hot. So you never keep it plugged on and keep it on the table, especially if it is a wooden table. You do not keep it on a table or over its wire. So what can happen is that it can melt the plastic covering of the wire and fuse the two wires, which can cause a short circuit or an explosion, a short explosion. So there is this holder for this. Always have to keep it facing down on the solder. So there has to be a sponge attached here. The sponge is containing water, so I don't have it right now. So whenever this gun becomes, the metals stuck, the solder wire gets stuck to the metal, you have to clean it using the sponge, and never to put your hands like this on the solder wire, or never to grip it like this. You have to always grip it over the rubber. And even if you get a burn from the solder wire, what you have to do is immediately, if you are outside and you don't have anything, you have to use water to cool it down. So it is not a very deadly burn, but it can cause a pretty nasty burn. And if you are at home and you don't have any water, suppose, then you can apply your toothpaste here. It usually cools it down. So when I was learning robotics, I had a burn, and Colgate, the toothpaste, was applied here. And if you want, if you can just hold it directly under water. You can also use toothpaste. It was just a secondary measure. You can also hold your hand under water for at least 10 minutes, or put ice packs over there. It will be okay after an hour or so. So I hope you guys enjoyed this video, learning about robotics, electronics, and getting some basic information about the components. Thank you for watching this video. Please don't forget to like, subscribe, and over and out. Thank you. Bye bye.